Hi, today we're working on a NuTone Model 2542 AM/FM cassette clock timer master station. And this particular one was sent in by Brad. Brad lives in South Dakota. We don't get a lot of cassettes in from South Dakota because I think in South Dakota they have more bison than they have people. I don't really know, but it doesn't seem to be a lot of NuTone in South Dakota. However, he just bought this really big house that has this really big system and it doesn't work. So we need to work through the different problems that it has and see if we can get it up and working. I've already had sort of a quick look at it, talked to Brad about what I saw, and he's all good to go on it. So let's go ahead and get started. Today's video is going to be focused on the clock, which does not work, and I'm going to show you why and what typically happens to these. In this close-up shot of the clock, you can see it's a fairly standard analog clock. You've got your hours, minute, and second hand. The second hand is the red one. It has a timer indicator, which is the white pointer way in the back next to the clock dial. Here you have the 60-minute timer switch, and over here you have the clock function switch. To set the clock, you use the clock function switch and you push it in and you turn it counterclockwise, which seems weird, but that's the way it's designed. And you can see the hour hand or the minute hand rotates, as does the hour hand, and so forth. And you just continue to rotate it by hand until you set it to the right time. I believe right now it's about 5 minutes to 2. To set the auto radio time, you push the knob in again and you turn it clockwise, and you'll see the white pointer move. And we'll set this for right around 7 o'clock because that's what time everybody should get up in the morning. Now, to use the clock function switch, here again, you'll notice that on the face of the clock, you've got this sort of grooved slot built into it. And if you look right at the top right now, there's a little orange pointer. And if I turn this, you'll see the pointer move down. So in the bottom position, the radio and the tape and the intercom are in the on position. So everything worked normally as if none of this was actually here at all. If we turn this up one slot, that's the radio off position, and that does just what it says. It turns the radio off. The tape player still works. The intercom still works. If you have a doorbell tied into the system, that still works. It just simply turns the radio off. If we move it up to the third position, which is the auto radio position, it turns the radio off and then back on again at your preset alarm time. So we have it set for 7 o'clock. It doesn't know whether it's 7 o'clock a.m. or 7 o'clock p.m. It's just 7 o'clock. So you have to turn this on at the appropriate time. For instance, as you close up the house at night, getting ready to send everybody off to bed, and you want the system to come on in the morning at 7 o'clock, that's when you would set this. So when you reach 7 o'clock in the morning, the radio will turn on to whatever station you have it tuned to, and it'll blast through the house and annoy all of your children and hopefully wake everybody up. Unless, of course, you have teenagers, and then that's not going to probably work. If you move the clock function switch to the top position, that's position number 4, that's the auto radio alarm setting. And what that does is it turns the radio off and then back on at the preset alarm time and sounds a mechanical buzzer that's built into the clock assembly on the back of the master station. The mechanical buzzer that's built into the clock is only heard at the master station. You're just basically hearing the mechanical buzzing sound that it makes. It's very horrendous and annoying. I'm not sure how much good that actually does because that buzzing sound doesn't broadcast through the entire system. You only hear it behind the master station. So it's kind of effective, but maybe not all that much. Also, if you move the clock function switch back down to off, it will turn the AM/FM radio off, but it doesn't affect the cassette player in any way, so you can still play cassettes on the system if you want to. Also, since the cassette player is also a recorder, you can also still record messages on a cassette if you need to, even though this is set to off. The 60-minute timer switch here is exactly what it says. You can adjust it between off and 60 minutes. And it's a little on the vague side because you have to line up the pointy edge of the knob with how long you think it actually is. If you turn it all the way up, obviously it's 60. So if you put it here, it's about 15, I would guess. And this is like a countdown timer. So if you set the function switch to off or auto radio alarm, it will allow the radio to continue to play until this times out, and then it'll switch the radio off automatically. For those of you who may have had kitchen appliances with a clock built into them from the mid 60s through maybe the early 70s, you might notice that this looks very familiar because this was also a popular type of clock and timer arrangement that were used on a lot of ovens and ranges and things like that. NuTone chose something that had a lot of functions built into it. Some of it seems a little redundant to me, but it was something that was already commonly available, and I'm sure it was a lot less expensive than having a company design something specifically for the intercom system. And it does give you a lot of functionality, and maybe in 1968 it was like a super cool thing to have because it would turn on and off on its own. And what else did that in those days? Nothing. You'd have to have some kind of mechanical clock to achieve something like that. Like most of the clocks in models like this and other models that use the same sort of clock, which there are other ones, there are alarm clock remote stations that were available for some systems, and they use clocks like this also. Like most of all these, this doesn't work anymore. And it doesn't work because of very specific problems that happens to them. And our job today is to see if we can solve that problem and get this one working again. So here we're looking down at the back of the 2542, and right here, this is the clock assembly. These clocks were made by the General Time Corporation. They were not made by the Telecron Company. They made clock assemblies for a lot of different kinds of clocks, for appliances, for tabletop clocks, mantle clocks, all different kinds of clocks. This is an entire assembly. They made the whole thing. Here we have wires that connect to the timer switch, which disappear down into a board over here. This right here is a neon lamp that illuminates the clock dial. This is the back of the motor assembly here. This little springy thing right here, this is our mechanical buzzer that makes the annoying sound when the timer goes off. And right here is the reason why it most likely doesn't work. Well, it's certainly the reason why it doesn't work right now. Could have other problems too, but we don't know. This whole clock assembly is powered by 110 because the entire 2542 has 110 coming into a socket, and this is the plug that plugs into that socket. And up here, right here where you barely can see, this is the low voltage transformer that's built into the set that powers the entire 2542 master station. Since there's 110 available inside the master station, and since the clock is a 110 device, it's wired in directly to these power leads that power the transformer. And you can see right here, this one's broken off. And I'm going to show you in a better view in a second what happens to this and why it happens. But this is a common problem. This one is also broken and loose. It may not be totally destroyed yet, but it's on its way. Part of the reason that this happens is this was a really poor design to wire it this way. The wires that are connected to it are much too heavy and stiff and brittle. And as they get older, the vinyl covering, the insulation covering on the wire gets more and more brittle. And then if somebody opens this up and they're poking around in here and they push on it, that's what breaks it loose. So we're going to see if we can solve all of this, at least for this particular case. These clock assemblies, the motors, all of this have not been available for, it's got to be 15 or 20 years. They just don't really exist much anymore, so they're very, very hard to find. Through the magic of having spare parts, this is an entire clock assembly out of another 2542 master station. I decided that we were going to attempt the repair on this one and see how successful we are with it before we take the other unit apart altogether. And you'll get to see how to take this out of the master station if we are successful when I swap out the units, the repaired one for the one that's in there now that's broken. So what do we have here? Well, here we have the clock mechanism with all of its gears and things inside. We have the clear plastic cover with the 4 screws that hold it in place. We have the motor and gear drive assembly with the little neon lamp. We have the clock dial, and we have the 4 hands. We have the hour hand, the minute hand, the second hand, and the timer hand, and then the clock dial itself. The clock dial is interesting in that, and I don't know how well you'll be able to see this. We take this up. When you work on something like this, you don't want to lose things. If you lose the hands for the clock, you're never ever going to find replacements for them unless somebody like me happens to have an extra set or an extra one that they're willing to send your way. So you have to be really careful. The clock dial is interesting because it's plastic of some kind, and you have this sort of circular grooved finish in the plastic. But on the other side, you can see the numbers in reverse, and if you look carefully, I think, you can sort of see through part of it. So when the light shines, you see the outer part is all black, and the middle is the back side of the silver part, and you can see the black numbers. So when the light shines down through the face of the light pipe, it will make this part glow, and you'll have this circular area here that lights up at night so you can tell what time it is, which is pretty ingenious. I kind of like that. What we're going to look at today is we're going to look at this motor, and then we're going to look at another motor. Okay, so I've removed some of the miscellaneous things, and now we have the coil and gear drive assembly and the clock mechanism. Let's put the clock mechanism off to the side for a minute and replace it with this. This is another clock motor assembly, which is the coil and the gear drive on this side. There's not a lot of information about these specifically that I could find online. However, these do seem to be relatively close in their specifications. There are some differences, but before we get into that, let's talk about what happened to this original one and the differences between this one. So this came out of another 2542 that I own, and here you can see the little wires with the neon lamp, and you'll also notice here that the tabs here and here where the wires would be connected for power are missing because they've broken off, just like the one in Brad's unit. And this is what happens to these. In this one, this is a new old stock unit, and it's never been used in any product before. And you can see this tab here with the little eyelet on it, and this tab here with the little eyelet on it. And this is where the power wires would be connected. These little tabs, the whitish colored parts here and here, this is made out of some kind of nylon or something like that. And what happens is over the decades, as this is on and running all the time, it generates a certain amount of heat. It doesn't get super hot or anything like that, but it does generate heat. And over time, it degrades the nylon material, and over time it makes it brittle, and eventually when somebody pushes on the wire or does something horsing around with it, it puts stress on it and it cracks it and makes it come loose. What you can't really see here, and I can't really necessarily show you really well, is you'll notice right here, here's the eyelet, and it's on the end of this little metal tab, and right here is a little heavier piece of wire or metal, and wrapped around it and soldered to it is the wire that comes out of one end of the coil. The coil is this part right here, this sort of tan colored area with writing on it, and there's one end of the coil attaches to this one, and the other end of the coil attaches to this one. And the wires that are used in this coil are about half the diameter of a normal human hair. They're very, very, very small. And what happens is when the tabs become brittle and crack and break off, and if you push on it, it'll rip the wire where it comes out of the coil down in here, and it's lost inside the coil, and then there's no way to fix it. And that's the problem. That's what tends to happen to these. This is an interesting design in that it's very much like a Telecron gear drive assembly, because this is actually a two-piece unit. So this is a two-part assembly. You can take the gear drive assembly out of the motor frame, which is this part, and what you have left is the coil. Now the coil is riveted together. You have this sort of X piece of metal here, and there's a rivet that goes through it, through the center of the coil, and another X piece of metal here. And when this was manufactured, somehow it was all assembled and then probably put into some giant press, and they squish it all down and squish the rivet thing in the middle closed, and that's what holds it all together. I suppose it might be possible to drill this out and then disassemble it and unwrap the coil, find the wires, figure out a way to solder to them, and then put this all back together, you probably could use a really small machine screw with a nut and a washer or something like that and squeeze it all back together. That's a project for another day. Whether or not this is the same one, I'm not 100% sure, but as near as I can tell, these are both 115 volt units because that's what it says. It's printed on the coil. This one, the original one, as near as I can read, it says 60C-115 volts, and this one also says, the new old stock one says 60C 115 volts. So 60C probably means 60 cycle. And 115 volts is obviously 115 volts, and that's good. And then on the original one, if you look really carefully, it says M5C-60, maybe something that I can't really see. Let's get the magnifiers and see if I can see a little better. It says 60 something, but I can't really make it out because this piece of metal right here is in the way. If you look at this one, this is an M5A and it says 60C. And maybe the 60C, oh, I see, it says 60C 115 volts. So it says the same thing around and around and around on the wrapper of the coil. So that's good. What's the difference between an M5A, which is this one, and an M5C, which is this one? I think the difference is what's missing on this one is there's no wires coming out of the coil for the neon lamp to backlight the clock. So if this does work, and I think it probably will, otherwise I wouldn't have bought it, we're going to have to come up with a clever way to power the neon lamp in some fashion that doesn't involve the coil for the clock, because there's no way that this is getting taken apart or anything's being done to this one, because that's a bad idea. So let's go ahead and put the original one off to the side and let's focus our attention on the replacement. So the first thing we have to do is we have to find out whether this is actually any good or not, because while the fellow I got it from said it was new old stock and said it was good, you never know. So let me get something and I'll show you what we're going to do. All right, so the first thing we need to do is we need to get some wires on this so we can put power to it and make sure it actually runs. And what I've decided to use is some of this. This is a super high quality silicone wrapped piece of test lead wire. And this is most commonly what you would use if you were building a set of test leads for some piece of bench equipment or something like that. It's rather expensive. However, it has the advantage of being super, super flexible, and it will never, ever get hard. And since our little motor assembly here, it's not going to really draw much in the way of current, you can get by with a smaller gauge wire than what was used in the set originally. I'm pretty sure that NuTone used the wire that they used because that was the wire they used throughout the entire set. And you don't want to have to buy extra kinds of wire. So I just made two random lengths of this right now. One of the reasons why that this is a good choice, in my opinion, is this has what makes this super flexible is this has lots and lots and lots of really, really tiny strands of copper wire in it, which makes it very, very flexible. So what we're going to do is we're going to strip some of this back. And we're going to attach it to this. Now, before I do that, I'm going to actually strip back both ends to start with, because even though this is new old stock, it's still conceivably 50 years old, and we don't want to pull or press or play on it any more than we have to, because if we break these and we're right back to where we started, and I don't want that to happen. So I'm just going to put this through the eyelet like this, fold it over, and solder it in place. Like that. And we'll do this one. like that. And now, once we've done that, the thing we're going to do next is we want to cover these up as they were in the original clock, because it is 110 volts, and even though it's unlikely that anything bad would ever happen, you certainly don't want someone reaching in there for some reason, and that's a little too small. I'll tell you how we're going to do this. We're going to make this a double layer. You don't want someone reaching in there to do something on the master station and they haven't unplugged it, which, you know, I wouldn't unplug it necessarily. I know what I'm supposed to touch and not touch. So we'll start with that. Get my hot air here. So this is just heat shrink tubing, and we're going to heat it up. And while the heater is heating, let me look for one other thing. Maybe this one. And as we heat it, it's just going to shrink. It shrinks about 2/3 of its diameter. And not only does it provide insulation over the connections where the 110 would be, but perhaps it will provide a little bit of added strength to the whole thing in case somebody does sort of tug on the wires. So I'm going to put a second layer. It's a bigger diameter, which will shrink around the nylon piece. Like that. Heat shrink tubing is one of those kinds of things that you should always have a wide variety of on your workbench, because you never know when or what you're going to need it for. Alright, like that. And then I think the last thing I'm going to do is I'm going to put the two wires together in one more piece. I'm going to gild the lily here just a little bit. No, that's too small. We've got one other size. That'll work, I think. Let's try some Go Fast Red. Nope, Go Fast Red's the same size. Let's try this. Alright, so I dug around in the bottom of the tray and I did find one piece of Go Fast Red that was a little bit bigger than the other one, and all I did was slip it around the two wires just basically to hold them together like that for right now. Turn this off, and then the other thing we're going to do is we're going to tin up the bare leads here a little bit, because that's the best way to do it. In the end, if this works out, the whole clock assembly will be put into the unit, and then these will use, they'll be soldered, but they'll also use crimped connectors like it had originally. So now what we need to do is we need to power it up to see if it actually runs. So I've got my connection for my bench power supply. It's an AC supply. We're going to set this to, we're going to go all in, and we're going to set this to 115 volts, which is right there, 115.1, close enough. We'll turn this off because high voltage there right now. We're going to go ahead and connect these, the two wires that we put on under the screws. And we'll carefully turn this over. Now, the little gear right here is supposed to turn. It's easier to see it turn if you put something on it that's bigger than just the gear itself. So what I like to do is I just take a little piece of electrical tape or scotch tape or blue painter's tape or whatever kind of tape you have, it doesn't matter. And we'll just wrap it on the gear just a little bit like this. It doesn't have to be fancy. It's basically just a flag that you can see turn. Now I'm going to turn the power on and see what happens. So either it's going to go around or it's not going to do anything, or there'll be a big cloud of smoke. Let's watch and see. Oh look, the gear goes around just like it's supposed to. It's not really drawing much in the way of current at all. In fact, it's so low that it doesn't even register on the meter on the power supply, but it does go around, and that's a good sign. So let's go ahead and turn it off. We're going to put this into the clock. Notice how it coasts down. Watch this. Watch again. So it's going around. And now I'm going to switch it off. 3, 2, 1, off. And see how it slowly coasts down? That's because it has gears in here. It has reduction gears, and the reduction gears give it momentum. Wants to keep going. There could even be like a little flywheel in there, and until the energy that's built up in the flywheel is dissipated, it's going to keep going. So now we need to put that back on our clock assembly and see if it actually works. Okay, so this is my donor clock assembly, and this simply sits on the back like this. And the gear goes through the hole for the gear, and there's a locating pin here which goes in a little opening right there. And then there are these two springy retainer clips, these, that sort of clamp the motor onto the back of the clock assembly. Like that. And this goes like that, and then these close. No, they're supposed to close. See, it fell out. Let's try it again. I'm sure that if I worked at the General Time Corporation assembly plant, I probably would have already assembled 10 of these while I'm here fooling around with just one. And there's probably some trick to making this snap together easily, which of course I don't know. Either that or they had some kind of specialized tool or something to squeeze all of this. See, there's these little metal brackets things right here that have a little notch in it, and the slot in the retainer has to go over that, and then it snaps into place. Of course, you have to do all of this. Now that wasn't too bad. Without breaking the little nylon tabs, because that was the whole point of doing this, was to fix it, not to break the tabs on the motor we just bought. And of course, oh, there we go. See, just all of a sudden it snaps into place, and there we go. So now our motor is mounted onto the back of our clock assembly, and there are all kinds of gears inside, which are really hard to see. I don't know if you'll be able to see that very well at all or not, but there's all kinds of gears down inside in here, lots more than in a regular clock, because you've got the timers and all the other things that go on. So I think the thing to do with this is to put the hands back on it to see if it actually runs and keeps proper time. We could put the face decal back on, but yeah, I suppose we can do that. Like this. Alright, now I do have people contact me occasionally about, oh, the hands on my clock have fallen off, what do I do? And the basic answer is you put them back on. So this is the timer hand, and I'll see if I can do this so you can see it. You can see right here there's a little slot. You can see the screwdriver go through the slot, and the slot goes to the inner opening of the ring. And basically this goes on first, because if you look at the first part of the video, you'll see it's the one that's furthest back. And this just goes into place, and the reason there's a slot is it makes the circular opening springy, and you just simply press it in place like that. Now you have to do the hour hand, because that was the next one, and that also has a little slot in it that's much smaller, but it's a slot nevertheless, and that one goes on next. And of course, part of doing this is, as you push the hands on, you don't want to bend them, because then they will, when they rotate, they'll be bent and they'll interfere with the other hand that's above or below it, and then it won't work properly. So here's the minute hand. It also has a slot in it, and that goes on next. And then finally, you have the second hand. And it also, even though it's orange, see, it's orange, it has a slot. So everything's got a slot. Alright, so there's that. And if we turn this, hard to turn without a knob on it. Let's try it this way. Alright. And now, if we push this and turn it, it's too hard to turn. Alright, well, we'll set it mechanically by hand to 12 o'clock. And now we're going to hook it back up to power, and let's turn it on. It hums a little bit, and the second hand goes around. So you watch that for a minute, and I'll be right back. Okay, that was more like 30 seconds, but that's okay. So here's what we're going to do. To make sure that it keeps time properly, and as with most clocks like this, there is no adjustment. It is what it is. It runs at the speed that it runs at. So we're going to do that. And we're going to zoom out a little bit. We have our trusty OXO general purpose timer. I rely on this. I use this a lot. You can tell it's all beat up and everything. It's got 3 timer functions, so you can time 3 things at the same time. And we'll reset it here. And what we're going to do is we're going to set it up, and we're going to make them both go at the same time. So ready, set, go. And we'll let it run for an hour or so, maybe longer, and see if within a few seconds if the time here and the time here are the same. So I'm going to leave this on and let it record for a while, and I'll be back. Okay, I'm back. So it's been an hour and 3 minutes, and it's 1:03 and 3 seconds, and here it's pretty close to, the face is a little wobbly there, but it's pretty close. So I would say it keeps accurate time. And if you sat there and watched it for the entire hour, good on you. While you were sitting there being mesmerized watching Brad's repaired clock, I was working on the backlight, or the light for the dial light. Surprisingly enough, so here's the little plastic piece that the bulb fit in, and I would have assumed that it was a neon lamp. And the reason of that is because neon lamps are often used in things like that because basically they never ever fail. They just will last forever. But it's not. It's a little incandescent bulb, and it was kind of glued in. And in the ungluing, it is burnt out, so it didn't really matter. But in the ungluing, the little wires that go to the leads for the filament tore off, but it was burnt. You can see the filament is burnt out. You can't see that, but I can. So I needed to come up with a replacement that would fit the plastic housing, that also would be relatively easy to incorporate into the circuitry of the master station for power, since we're not getting power out of the coil anymore. The way this will work is this actually slides on here like that, and then the bulb goes inside. So what I came up with was this. This is the pilot lamp for the indicator on the master station that the system is turned on, and I modified it a little bit. It has these little springy lever clip things like this that were part of it, and I bent those and snipped them off with a pair of tin snips, and then put a lamp in it that would be a pilot lamp for a 2540 or a 2542. There's one of these in his master station also, and it's a replaceable bulb, so it's good, and I can fit it into the sleeve like this. I'm going to grind out the inside of the plastic sleeve just a little bit so the socket will recess in just a little bit more, because I think that will be better. And then I'll put some heat shrink tubing around the socket body to insulate it so we don't get any kinds of short circuits. And the way this basically works is, let's turn the clock off. We don't want to tempt fate here. And we'll turn the light bulb on so it glows. And this light bulb will last if it's on continuously, it probably will last 8 or 10 years, which is pretty good. And the way this works is, it's very simple. The portion here, this clear plastic piece, which you saw in the beginning of the video, bends over and goes down and fits behind the part of the clock dial that is not black. And basically, it's a light pipe. So when you put the bulb in the socket, or you put the housing on the light pipe like this, and you put the bulb in the housing, and when you turn it on, the light from the bulb shines through the slot, travels through the plastic, that's the light pipe part, down, and illuminates the plastic all the way down behind the dial face, and that's what makes it light up so you can see it at night. Which I don't think I've ever actually seen one of these lit up when it's dark, because I think at this point they're all old enough that the bulbs have all burnt out. So that's fine detail work that has to be sorted out as things move along, not so much for today. So I hope you found this interesting, and maybe for someone it will be helpful. If it is, give it a thumbs up on YouTube, because that helps us just a little bit. There'll be a banner right here that shows you how to subscribe. Go to our YouTube homepage, click on the bell, and when you click on the bell, click on it to receive all notifications, and every time we post a new video, you'll get a notification and you can watch it. The next part is we're going to take a look at Doug's cassette player and what it takes to get that working again also. See ya.